Welcome to Ask and Learn.
In this problem, we are learning how to use logarithmic differentiation to find the derivative of a function. So we are given the function y equals the cosine of x raised to the x. Now, using logarithmic differentiation is going to be very helpful in this case because we can simplify that exponent using log properties. So the first thing that we're going to do is take the natural log of each side. So we would get the natural log of y equals the natural log of the cosine of x raised to the x. And now we can essentially factor out that exponent and put it in the front of our equation or of our expression. So we would get the natural log of y equals x times the natural log of the cosine of x. And now this looks much easier to calculate using product rule and also chain rule instead of using a more complicated route. So we would derive each side of our equation. We would get d natural log y dy times dy dx equals the dx dx times the natural log of the cosine of x. And then we would have to use chain rule because of this composition of functions, plus x times d natural log cosine x over dx. And then we can simplify this to get 1 over y times dy dx equals 1 times the natural log of the cosine of x plus x times 1 over the cosine x times negative sine x. And now we can simplify to get a much nicer equation. We would get 1 over y times dy dx times the natural log of the cosine x minus x times the tangent of x. And then we would want to put y on the other side. We'd multiply by y to get our differential by itself. We would have dy dx equals y times the natural log of the cosine of x minus x times the tangent of x. But we know y. Y is the function we started with. So we're just going to substitute that back in. So we're going to get dy dx equals the cosine of x raised to the x times this entire quantity, the natural log of the cosine of x minus x times the tangent of x, and that is our derivative. I hope that this problem helped you understand how we can use logarithmic differentiation to find the derivative of a function.